superbly adapted, where they have these amazing antifreeze, again, lots of antifreeze going on here to keep those little eggs from freezing and those little fish from freezing. And so for a long time, we didn't even know where their eggs were until a biologist found them there in the platelet ice. And we were able to actually find a new nursery ground for them. Toothfish are actually the opposite of the silverfish, where the silverfish are key prey species. Antarctic toothfish are the top fish predator in the Southern Ocean. This picture gives you an idea of how big they get. They grow in excess of 2 meters and 140 kilograms. And these fish actually act as the shark of the Antarctic. There aren't any proper sharks in the Southern Ocean waters in the high latitudes. So these fish act as that, they fill that niche. And the Antarctic toothfish is actually what first brought me to Antarctica as a graduate student studying their life history. And we did show they live up to 40 years old. But more than that, like, they are this extraordinary fish. Again, they have lots of antifreeze in their blood. And they also, if you can see the graphic in front of you, they also have these other amazing adaptations. Most fish actually have swim bladders, which are air sacs in their bodies that control their buoyancy so they can move up and down. Toothfish don't have swim bladders. They're neutrally buoyant, okay? So they have a highly ossified skeleton. They have a lot of fat in their tissue, and so they're actually neutrally buoyant, essentially weightless in water. And we've been discovering more and more about their life history, and potentially that they make this amazing spawning migration out to the northern parts of the Ross Sea, and that they do that through passive migration with the currents. So we've been trying to test this hypothesis because this is a remote part of Antarctica. A lot of people don't know a lot about their life history, but for the last 10 years, we've been trying to understand through modeling, is this what they can do? And also through vessels have been sampling on the water as well when they can. But it's this amazing journey that they potentially make. And again, being neutrally buoyant, just passively migrating with these very strong currents in the Ross Sea. And again, we know so little about these fish. The Antarctic toothfish, the first egg of a toothfish was only found in the last year or two. So we really have a lot to learn about these animals. Toothfish are also key prey species. So they are a top fish predator, but they're key prey species for large mammals like this Weddell seal in front of you, which is holding a toothfish. These unique fish with their amazing adaptations were actually once only known and studied for their fascinating polar biology, but now the Antarctic is emerging as a resource frontier. In fact, the reason I had funding to study the life history of toothfish was because there was a growing commercial fishery in the Ross Sea, which operates still today under so much uncertainty. And I have to say, when I first started studying this fish and first got to go to Antarctica, I was really surprised that we were fishing in Antarctica. And the pictures in front of you give you a sense of what it's like there. But these are on mild days. On a normal, calm summer day, you can get up to 10-meter swells. And as you can see, vessels are constantly in the ice, and these fishing vessels are not icebreakers. They're not ice strengthened. They're just fishing vessels, and they're out there fishing. So it is an extremely dangerous place to fish. But part of the reason that we're sending vessels to Antarctica, that literally we're sending them to the most remote waters in the entire world, risking their lives, is because of global fishing trends. The map in front of you shows in red fisheries that have reached their maximum catch. So this is a map from 1965 where most of the fisheries were close to shore, and these in red again is just areas that have reached their maximum catch. This is from the Millennium Ecosystem Assessment that was released in 2005. This is the same map from 1995, showing that by 1995, we had reached peak catch throughout much of the world's oceans. And the trend is that vessels move further and further away from continents, from ports, and they move into deeper and deeper water. So more remote, more deep, that is the trend. And that is exactly the trend that has brought fisheries to Antarctica, to these most remote stretches on Earth, the furthest away from ports that you can go in very deep waters. And actually, more recent statistics by the United Nations have showed that 90% of our fisheries are overexploited, fully exploited, or collapsed. So we really have few pockets left in the world where fisheries can expand, and the Antarctic is one of them. So some of you might not know, what do we fish toothfish for? Well, here in the United States, it's sold as Chilean sea bass. I know it's largely sold in Europe as well, the US, Europe, and Asia. And again, these fish were once only studied for their crazy adaptations, and now they're sold in increasing numbers for commercial markets. And as I noted, there's a lot of gaps in their life history, and so it does make sustainable management challenging. Yet, due to their high value, they're also called white gold because they're so valuable. More and more nations are searching for new grounds and pushing for higher catches. But the largest fishery by biomass is actually for Antarctic krill. These are small shrimp-like crustaceans which form the basis of the entire food web. They're potentially the most abundant animal on Earth, estimated at 300 to 500 million tons of krill that live around the Antarctic continent in the waters. And yeah, really everything eats krill in the system. The penguins, the whales, the seals, many fish. So they really do form the foundation of the food web. And yet there's increasing pressure to harvest krill, not for human consumption, they're actually not really fit for human consumption, but for sale and fish meal operations. So what you're seeing in front of you is a picture of krill harvest and then fish meal. It's ground into fish meal to feed pigs and chickens and salmon and other aquaculture, and also to be turned into omega-3 pills for nutrition supplements. So there's increasing pressure on this fishery as well for those two markets that are expanding. And this map just gives you an idea of the fisheries operating in the Antarctic today. Each flag on the map represents a vessel from that country which notified to fish. And hopefully you can see, I mean, this is the Antarctic Peninsula region, and further north, very busy international space for fishing, as well as the Ross Sea down here. Meanwhile, the system is absolutely struggling to adapt to climate change. If you follow any news at all, you're probably hearing a lot about ice shelves collapsing and glaciers retreating. And that's especially in this area, if you can see my cursor, around the Antarctic Peninsula. Climate change is complicated in the Antarctic. There's a lot of natural variability that has been happening, and then there's the human-induced climate change, and scientists are working hard to tease the differences out between those two. But it is one of the most fastest changing places on Earth, the Arctic and the Antarctic. And basically this figure is trying to summarize that story for you. And in general, red is areas that are warming, experiencing collapse. Is the yellow dots are areas experiencing collapse. And in blue are areas that are actually cooling. So again, it is a complicated story, but it's changing. For sure, we know it's changing. And in this environment where I've already explained with the fish, it's superbly adapted to the cold and to the ice. These changes are causing impacts throughout the whole system. And again, where scientists are just really starting to tease out what is from climate change, what is natural, what is from fishing, what is from other impacts. And to summarize those impacts, this graphic tries to do that for you, where you can see there's increased human threats from fishing, from tourism. Tourism is increasingly popular in Antarctica, at least it was before COVID. We'll see what's going to happen to it now. There's increasing science operations. And then there's, as I mentioned, these climate change impacts like warming, but also acidification. There's been biodiversity shifts, and in particular changes in the distribution and abundance of penguins and krill. Krill are actually contracting in their range and shifting. I realize this sounds really dire. The story of climate change is really dire, but there are solutions. So global threats to ocean biodiversity have actually generated a worldwide movement to improve conservation and management, with marine protected areas emerging as a tool. And these are defined as areas where human activities are restricted to meet specific conservation, protection, or fisheries management objectives. And they're becoming an increasingly popular tool for conserving marine biodiversity. We've used protected areas on land for a really long time, but they're really emerging now in the ocean space with international agreements now calling on the whole world to develop marine protected areas. And there's a reason why they're increasingly popular, and that is that more and more studies are showing that they work really well at conserving marine life. And this is just one study that was a meta-analysis of 124 marine reserves in 29 countries. And you can see in the figure in front of you, they showed that biomass, so the amount of stuff living in the water, increased by 446%. That's dramatic within the marine protected area. The density of animals increased, and the size of individual animals, and the species richness also increased. And this is one meta-analysis, again, of many that have been done since then. So perhaps most importantly for a space like the Southern Ocean, like Antarctica, marine protected areas can enhance resilience. Basically, because they maintain all the trophic levels of the ecosystem and they increase species and genetic diversity, they can enhance resilience to environmental change, including climate change. So how do we develop marine protected areas in Antarctica? Here, this place at the bottom of the world. Well, that relates to this other question. who governs Antarctica? Who's in charge? Who's in charge to set up protected areas here? Well, if you know anything about Antarctic history, maybe you do or not, there's a very rich history of exploration. In fact, countries are still debating who discovered the continent. Was it Bellinghausen from the USSR, Palmer from the USA, or Bransfield from Great Britain? They all saw the continent for the first time in 1820, these three explorers, and all potentially contest that they discovered the continent. In Antarctica, it's a place without indigenous people. Some had actually potentially moved through there or seen it, but not lived there, not sort of colonized the space. And so it was this unoccupied space. It really was the last frontier, and all these countries were competing over who it would belong to. And explorers, largely from the rest, planted flags. They were mapping, claiming the space for their home countries. So by 1942, this is actually what a map of Antarctica would look like. It was divided up like a pie, with some countries fighting intensely over those claims. You can see the 7 countries that made those claims were Great Britain, Chile, Argentina, Norway, France, Australia, New Zealand. And then there were 2 other countries, the USSR and USA, who at the time reserved their right to claim the whole thing. So tensions were really building. So as I mentioned, this is a map by 1942, these claims were laid out. But in the 1950s, tensions were really building over some of these claims. We had competing superpowers of the USSR and the USA launching the first satellites, getting ready to launch atmospheric rockets from Antarctica. That was happening in the 1950s. And there was growing fear that science rockets would lead to nuclear missiles, and that Antarctica actually would be used as a launching pad for nuclear war. And particularly for some Southern Hemisphere countries, they felt, Russia has this huge space in the north, and now they're going to have this huge space in the south, and potentially we will have nuclear war launched from both places. So there was a real fear that Antarctica would be used as a space for international discord, really, and would lead to it. But then an amazing feat of science diplomacy happened. There was a 1957-58 International Geophysical Year, and this was a year focused on international science collaboration in Antarctica. And it set up this amazing framework for science collaboration, which actually led directly to a political collaboration and the signing of the Antarctic Treaty in 1959, which set aside the entire continent for sake of peace and science. Amazing agreement. Like I said, we had all these tensions, and then suddenly we had this amazing framework for science collaboration that led countries to decide to do a political collaboration. And the treaty originally had 12 signatories. Now it has 53, and it is an amazing agreement. It's the first post-World War II arms limitation agreement. Collectively, it grants freedom of science and actually has open science sharing, data sharing. People can share science bases and resources. It prohibits military operations. So military operations are not allowed in Antarctica. It prohibits nuclear activities. So this is one of our largest nuclear-free zones in the world. And it suspends sovereignty. So those claims I mentioned to you, completely suspended under the signing of this treaty. And later amendments to the treaty actually also banned mining. So I have to pause and highlight how remarkable this is, what I've just told you, that we had this space that was claimed, that was divided, and instead of continuing to fight over it, and instead of potentially using Antarctica as a space to launch war, we actually came together, signed a peace treaty, and set it aside for the sake of peace and science. It's a de facto world park, and I truly believe it's one of our greatest achievements. It's a space that belongs to all of us now. It's truly a commons. So under the Antarctic Treaty System is another agreement which governs the oceans. So the treaty largely deals with the land and the seabed. It doesn't deal with the oceans itself and all the things living in it. So the Convention on the Conservation of Antarctic Marine Living Resources, or CAMLR, is the agreement that deals with the oceans around Antarctica and the marine life. They currently have 26 member states represented by the flags on the screen in front of you, and all decisions are made by unanimous consensus. So any policy decision needs every country to agree. In line with the principles of the treaty, grounded in science and precaution, CAMLR is actually considered a leader in marine resource management. They allow for fishing, but under the idea of rational use, and all activities are bound by the precautionary approach. They have to incorporate the best available science and consider all ecosystem impacts. So they're considered a leader because of this, because they have strong ecosystem management. And in line with this leadership, CAMLR has always had legal provisions for marine protected areas. So when we come back to, okay, how do we set them up in this space? Well, we actually can. And working towards international targets, which I mentioned had called for a global network of marine protected areas, CAMLR's been working towards a Southern Ocean-wide representative network of protected areas. The map before you shows the 9 planning domains that they've designated to help guide this work. So I've told you a lot of information so far. I've told you that Antarctica is full of amazing biodiversity. I've told you it's highly threatened by fishing and climate change, but that we have an excellent framework for management, which includes protected areas. And all of this leads to an opportunity to study a major research question, which has really guided my work over the last 8 years. And that is, under what conditions can international institutions effectively conserve the global commons? And to answer this, I've been studying the CAMLR MPA process to try to understand how do we come to agreement on large-scale protected areas in a commons. In particular, I want to hone in on the Ross Sea Antarctica. This was a priority area for protection early on for the whole world, and part of that is the map in front of you. This was a global assessment of human impacts on the world's oceans that was published in Science in 2008. And in that assessment, the Ross Sea actually stood out as the healthiest, least impacted, or most intact large marine ecosystem left in the world. So this is truly amazing. The map in front of you shows, again, how much we have damaged the world's oceans. The spectrum goes from red to blue. Red is the areas that are most damaged. So parts of Europe, parts of Asia, parts of where I'm from, actually in the Northeast United States is where we've most damaged the oceans. And we only have a few pockets left that are blue, largely in the Arctic and the Antarctic. And again, to highlight that the Ross Sea, which is where the arrow is pointing to, was considered to be the least impacted or most pristine marine ecosystem left in the world. So not only is it intact, it's actually the most productive stretch of waters in the Southern Ocean. This is a photo taken from NASA, from space, of the annual summer phytoplankton bloom in the Ross Sea. So the green is all phytoplankton, and they have this massive, amazing bloom every summer that you actually can see from space. And that massive bloom of productivity drives this amazing ecosystem. The Ross Sea supports a disproportionate amount of marine life, including 35% of the world's Adelie penguins and 25% of the world's emperor penguins, and a variety of other mammals and underwater marine life as well. So I really need to highlight the efforts of this man in front of you, Dr. David Ainley. He had been working in the Ross Sea for decades. He saw the threat of the fishing industry early on. He was working there studying penguins, and he literally saw the first fishing vessel come in and thought, oh my gosh, this is really going to disrupt this ecosystem. And he knew he comes to the Ross Sea to study an intact ecosystem so that we know what a healthy marine system is supposed to look like. So he saw the threat of the fishery early on and began advocating for protecting this place, arguing that we need at least this last place kept intact as a living laboratory so that scientists can study how a healthy marine ecosystem functions, particularly under climate change. So in 2002, he actually submitted a rather obscure policy paper directly to CAMLR, making his case for protecting the Ross Sea. And over the next many years, he actually galvanized the support of hundreds of scientists from all over the world who began advocating to protect this place. Early on in this process, David's obscure paper got into the hands of a Boulder, Colorado-based conservation photographer, John Weller. And they teamed up to tell the story, branding it as the last ocean. So trying to get into people's minds the idea of this last intact place. So while I was still researching life history of toothfish, John actually found me. He convinced me to join this Last Ocean project and to engage in this media and science policy project. And then he actually convinced me to move to Boulder, Colorado, which is where I'm based now, and to marry him and to have his children and to stay here. And I will tell you the next part of our journey now. And I actually wish I had more time to tell you about this amazing 10-year media journey we were on. We created a flood of media around the Ross Sea in support of its protection. And we made efforts to bring this to policymakers. So what you're seeing in front of you is some of the media and some of the policy reports, including some of them in multiple languages that were really focused on reaching policymakers. We really worked to reach the public. So what you're seeing in front of you is all kinds of media we created that was more public facing. We worked with New Zealand filmmaker Peter Young to produce an award-winning documentary that told the story of the lost ocean. And we created a stunning photography book, which we actually delivered into the hands of all of the CAMLR decision makers so that they actually could have the story in their hands. And there were millions of public citizens which engaged in this campaign. I've sort of highlighted the work that our media did, but there were a whole variety of conservation groups all over the world that were involved in this campaign and really pushing for it. And the picture in front of you is actually a scene outside of CAMLR where the public is out there protesting and calling for protected areas. And there was this amazing moment in the process, actually in 2013, when former Secretary of State for the United States, John Kerry, went to an event in Washington, D.C., saw a shortened version of the Last Ocean, and actually became committed to protecting the Ross Sea as part of his legacy. He wanted to be part, something to happen in his term. Kerry would actually prove incredibly important in this room. This is the room in Hobart, Tasmania, Australia, where CAMLR delegates meet every October to make policy decisions. This room is closed to the public. You actually have to be on a delegation to be able to be in this room and to engage. And I knew that when a Ross Sea MPA proposal was tabled to CAMLR in 2012 by the United States and New Zealand, that I had to get into that room. So I mentioned there was David Ainley started this effort in 2002 with his first paper. 10 years later, finally, a proposal for a marine protected area was coming before this international body for decision making. And that was the year that I started my PhD, and I really wanted to study this process. So I managed to sit on one of the few observer delegations to CAMLR and to get a seat in the very back of the room. You can literally see me, I'm in the corner of the room, which is where I was able to sit and study this process as a participant observer. This is a role I still fill today, observing and participating in the process. And I've been able to watch and study this fascinating process of governments moving towards consensus agreement on large-scale conservation issues in the Antarctic. And in the case of the Ross Sea Marine Protected Area, at the time, CAMLR had 25 member states. And again, to remind you, all decisions are made based on consensus. And again, here's the Ross Sea Marine Protected Area. So this is the map you're seeing in front of you is a figure of that protected area as it looked in 2012, again, proposed by the US and New Zealand. And I'm just going to quickly show you this process of how you build a consensus, how you get every country to agree. Well, in 2012, actually, when the proposal first came to the table, more than half of the member states supported it, straight as it was proposed. But you might see on the screen, these were largely Western countries that supported a protected area agenda already. In 2013, so if you look at the map for a sec and watch, that's the map in 2012, this is the map in 2013. So a lot of the areas in the north were removed, and these were removed in part to meet the concerns of some fishing states. There is fishing in the north there, and some countries like Norway felt there was too much uncertainty in the science to remove those areas from the, to keep those areas in the proposal. So some key fishing states started joining in consensus once we removed those northern fishing areas from the proposal. In 2014, more states joined a consensus, including Ukraine. That was a fascinating thing because prior to 2014, they voted in unison with Russia on these issues. And after the annexation of Crimea, they stood on their own and actually stopped opposing and even began supporting a Ross Sea Marine Protected Area. Other states joined in too, in part because over all these years of negotiations, the United States and New Zealand were working with individuals in the room, building trust and working towards clarifying this process. China joined in 2015 with the addition of a krill fishing zone to the protected area and an agreement for the protected area to have limited duration. Though we heard stories from our colleagues who work close to the White House that China really came to consensus due to diplomatic pressure. Our understanding was that, again, former US Secretary of State John Kerry had been hard at work in China and managed to get our former President Obama to incorporate a Ross Sea MPA negotiations into broader climate negotiations between China and the US. And of course, that left Russia standing on their own. So coming into 2016, the Ross Sea Marine Protected Area had been under diplomatic negotiations for 5 years, with 10 years of scientific and public effort behind that. So Russia was isolated at this point. Secretary Kerry's term was coming to an end. There was a real political window of opportunity, a lot of pressure on this moment. And at the same time, there was an opportunity for Russian leadership. Russia was chairing the meeting that year. And 2017 was declared as a year of ecology in Russia. And the country was actually also, if you remember, coming upon their 200th anniversary of discovering the continent. So there was this political window of opportunity, this opportunity for leadership. Still, though, negotiations were really intense. They went on until all hours. We, as observers especially, were often kicked out of the room as the diplomats held private head of delegation meetings, and then the chair would invite us all back, and we would think we're at consensus, but then another country would raise an issue. And the meeting went on like that for 2 weeks. And it was Thursday night on the second week of the meeting when the chair finally came back into the room and said, "We have consensus." And the room exploded in applause. And you normally don't see that. You're seeing this picture in front of you. It's normally serious delegates wearing suits. But in this moment when we had consensus, the room exploded. Everybody was clapping. Countries were hugging other countries. Some of the scientists were literally crying. And I realized that, like the signing of the Antarctic Treaty at the height of the Cold War, the adoption of this protected area was a diplomatic breakthrough, where we got the United States and Russia and all these countries to agree to do this for the sake of future generations. And it was an immediate source of pride for everyone in that room. After its adoption, the Secretariat invited all the delegates to come and sign this map of the MPA, and it actually is still framed in the CAMLR office to this day. So you can see, if you look at that map in front of you, you can see the signatures of individuals from so many different countries who came to agreement on this day. And at more than 2 million kilometers squared, and 70% of it is no take or off limits to fishing, it's still the world's largest marine protected area. And again, it belongs to all of us. It belongs to me and to you and to the whole world. So reflecting back, how did we get consensus? Well, in summary, we worked at the intersection of science, policy, and public engagement. And I cannot underestimate the role of public engagement, the huge scientific effort combined with that high level diplomacy, negotiating trade-offs, economic trade-offs, geopolitical trade-offs, building and at times breaking and rebuilding trust, working with opportunities for leadership, which all led to this amazing political window of opportunity. So the Ross Sea is a start, but we need more. And to remind you, CAMLR committed to a network, so a whole system of marine protected areas that would represent biodiversity and key ecological areas throughout the entire Southern Ocean. The map in front of you shows the existing marine protected areas in gray. So in gray are all the protected areas that already exist. You can see some of them around the sub-Antarctic islands. These are under national jurisdiction, these other gray ones. And the CAMLR protected areas are here in the Ross Sea. And blue means no take. So gray and blue are existing protected areas, where blue is all the no take. And we have we have a small one here around the South Orkneys and the large one in the Ross Sea. Now the areas that are in hashed lines are the proposals on the table. So we actually have 3 large proposals, one in the Weddell Sea, one in the Antarctic Peninsula, and then one spread throughout the East Antarctic. So these proposals are actually on the table under negotiation right now for CAMLR as we work towards this network. And yeah, again, just a major criteria for conservation is that protected areas actually be ecologically representative, because their efficacy is enhanced when they actually represent biodiversity of the region. This is especially important in mitigating climate change impacts to ensure we protect really vulnerable areas and vulnerable species, as well as protecting areas that might be stronger or more resilient. And the figure in front of you is just showing regionalizations that we've done, where we looked at what are the different pelagic regions, what are the different benthic regions, and then trying to look at where do the protected areas need to be to include all of them. And right now, the existing and proposed marine protected areas aren't enough to ensure that we give the Antarctic species the best chance of surviving in the future. Now for me, it's become personal. I really want my children, including my daughter Adele in front of you, named for the penguin, and her brother Orion Ross, and Ross his middle name for the Ross Sea. I really want them to live in a world thriving with Adelies and Antarctic marine life. And Adelies are really in trouble throughout Antarctica due to climate change. And in the 15 years that I've been going to and studying Antarctica, I've witnessed some of these dramatic ecosystem changes. And perhaps most unsettling, again to me, because I named my children after Antarctic wildlife, was to see how on my last trip to Antarctica this past December, Adelie penguins, again my daughter's namesake, had almost completely disappeared from the Antarctic Peninsula region. And let me elaborate just a little bit further on the significance of this shift. So Adelie penguins nest on the few small patches of ice-free rocky land throughout Antarctica. They build nests using pebbles, precious pebbles, which are relatively difficult to find in this icy landscape, and they spend tremendous energy collecting and rearranging these pebbles into nests. Every nesting season, the Adelies come back to the nest that they built the previous season. And this ritual has been carried out for thousands of years in some colonies, thousands of years. To witness the abandonment of some breeding sites in a matter of years is a dramatic change, to say the least. The Adelies are moving south, but as the south warms, they'll have nowhere else to go. So in my daughter Adelie's lifetime, she may see the disappearance and most certainly a drastic reduction of this species that is her namesake. Indeed, just this February, so just 6 months ago, the region I visited saw its highest recorded temperature ever. So the news article in front of you is highlighting that, more than 20 degrees C, this part near the Antarctic Peninsula. So super, super warm for these species that are again, superbly adapted to the cold. So all that I witness is supported by robust science, and it's not just remote polar animals that will suffer. Over the last 30 years, the IPCC, which I think probably most of you are familiar with, it's the authoritative Intergovernmental Panel on Climate Change, has released dozens of reports, literally dozens of reports, and they're all reconfirming with ever more science the state of our changing planet. But the message embodied in the most recent report, which is focused on the oceans and cryosphere that just was released last September, had the most bold and urgent message to date. It really stated that all people on Earth depend directly or indirectly on the ocean and cryosphere, and the cryosphere being the ice system, and that we need to act now or future generations will suffer. And just to summarize, this report was devastating to read. It really went over how the glaciers and ice sheets are melting. Sea level is rising, in part because of the melting in Antarctica. Oceans are warming, they're becoming more acidic, and something new that came out of this report was that oceans are actually losing oxygen, right? So oxygen is obviously what everything needs to live, and oceans are losing that. 50% of our wetlands are gone, species are shifting, biodiversity is declining, and ecosystems are actually losing their integrity and function. So why does this matter? Because these will all have direct and indirect impacts on our health, human health, food security, fresh water, and livelihoods. And again, the message in this report really was, if we do not act with urgency, we and future generations will actually suffer greatly. But this report also had some solutions, like it had some policy recommendations of what can we do? What can we do in this dramatic space? Well, two of the major policy recommendations were to reduce emissions in large-scale protected areas. So reduce emissions is an obvious one that we keep talking about. We know we have to do this across the world. Marine protected areas will not work in isolation. They will not work if we continue to carry on as normal and pollute the world as we've been doing. But the solution in this report and many others was pushing for large-scale protected areas, particularly large. If they're large, they really can encompass life history characteristics. They can encompass the migration areas, the breeding grounds, foraging grounds of animals. And so large is really important. And as I mentioned, having all the key biodiversity areas in those protected areas is important. And the reason for that, again, is that if you reduce human impacts, if you get rid of fishing and other human impacts, you give that system the best chance of being resilient and adapting to the environmental change that's happening. So I really hope you've enjoyed this Antarctic journey, and I hope you understand how Antarctica provides a fascinating space to study life history at extremes and to study intact marine systems, but that this incredible place and the wonderful species that live there are under great threat from overfishing and from climate change. I hope you have also seen that the Antarctic provides insight into how to conserve the global commons. In the Antarctic, we have adopted large-scale protected areas, which really does provide hope for the future. We've seen we can do it here, we can do it again, we can do it elsewhere in the world. Although again, as I've noted, we need to do more. And we actually have the opportunity to do more in 2020. CAMLR governments are scheduled to meet next month. It's unclear if and how they will meet. They are working on meeting virtually to try to make decisions. But normally they would meet in October, and hopefully they will meet this October and have the opportunity to study this or to make decisions on further protected areas in Antarctica. So please do stay tuned and follow on that. And with that, I have to thank my funders, past and current, especially the Pew Charitable Trust. I really need to thank all of those who gave me access and technical support, and to my core collaborators, though there are many more who deserve to be named. And I really would love to thank you for your attention. And with that, I'm happy to take questions. Thank you so much.
Thank you, Cassandra. Beautiful talk, really inspiring. I guess, yeah, there should be questions. Just to remind quickly to people, you can either ask via the chat and I will redirect it to Cassandra, or if you can raise your hand, I will just unmute you. I just see that Bruce is raised his hand and you should be unmute. Yeah.
Hi, Cassandra. This is Bruce Vaughn. I'm actually also from Boulder. I have to go to Vienna to hear you, though. Thank you for that fascinating, wonderful talk and explaining the whole problem down there. And I'm really curious about your view for looking to the future for enforcement of fisheries in the Southern Ocean. I just read Ian Urbina's book, Outlaw Ocean, which I'm sure you're familiar with. It gave me a rather pessimistic outlook for how challenging and daunting this is to enforce these protected areas. And I'm curious about your thoughts.
Bruce, thank you for that question, and great to see you here. And when you come to Boulder, let me know if you make it back to Boulder. Yeah, I think that's a huge issue. In the Ross Sea protected area so far, in the protected area itself, the countries who fish there were involved in the agreement, and so they have agreed not to fish in there, and so far so good. We haven't seen illegal fishing, but the issue of illegal fishing in the Southern Ocean remains to be one that is significant. And yes, if folks have not read Ian Urbana's book Outlaw Ocean, please do read it. It's a fascinating account of fishing in international waters and how absolutely dangerous and treacherous that is. And to that, the Southern Ocean, CAMLAR has done a good job of reducing illegal fishing through having really strict measures on tracking toothfish. So they have a lot of rules on, like, when you catch toothfish and you land it, it is traced along the way. They have agreements with states where you would drop the toothfish. So the port states, they actually have agreements for these having to be legal operations. But I think one of the biggest issues that CAMLAR hasn't dealt with at all is slave labor on these vessels, and how do you, in human rights issues. And there are a lot of toothfish operators that they are renowned for their sustainability efforts and whatnot, and for having this ecosystem approach. But when you ask them about, well, what about human rights issues on those vessels, they haven't dealt with it. They don't know how to deal with it. And I sometimes feel like they don't necessarily want to deal with it. And part of that is it's very expensive to go to the Southern Ocean. And the United States doesn't fish there. And even when I asked about that, I asked my colleagues, why don't you fish there? We import so much toothfish, we sell it, why don't you fish there? And they said, oh, our labor laws are too strict, and it's too expensive for us to send vessels and to pay people what we would have to pay them to fish there. So you end up with vessels going down, with some of the flag states having literally slaves on board, working for free or worse, to collect these fish. So I think that's an issue that we all should be thinking about, human rights, not just sustainability, but the human rights issues, and how do we actually push for that? Because I think if we have better human rights, then it solves a lot of the actual illegal fishing operations. So that's where I'm at with it right now. So thank you for that question.
Thank you.
There's a question from the chat from Emma. Great talk, thank you. Do you have advice on how to engage your science with policy media, particularly when you don't have such engaging photos?
Yeah, it's just marry a photographer. That's like tip number one. No, I'm very lucky to have these beautiful photos. I would say there is a lot of stuff publicly available. I do think media is very important. And even if you don't have beautiful, engaging media, to know the audience that you're engaging with. So if you are looking to engage with policymakers, you don't necessarily write a peer-reviewed paper. You might write a white paper or policy paper that gets submitted to a meeting. You might work with a conservation group who can help you get your information in. Or if you do publish peer-reviewed papers, it's making sure that you push them out into the world and get them into the hands of policymakers. And that's something that I try to do. I try to have my graduate students do, so that we're not just yeah, publishing in isolation, especially when we're working on issues of climate change or conservation. I think we have to be proactive about getting our research into the hands of the people who make decisions. And then, yeah, but I do think us as scientists, not everybody is comfortable communicating or even advocating their science findings. But I do think it's important for us to have a voice and to feel comfortable using it. And again, if you don't have to advocate policy, but you can advocate for your science findings and to make sure your science clearly gets communicated out. So thank you, Emma.
There's another question from Søren. Thanks a lot for the talk. Do you know what the current status of the CAMER effort is on implementing an MPA in the Weddell Sea?
Yes, I do. So yeah, the Weddell Sea has been negotiated since 2016, I think, and had some changes along the way. And now it is broken up into two protected areas, one in the eastern and one in the western Weddell Sea. So that's the sort of current status. And the western Weddell Sea section is up for protection first, or up for discussion for protection first. So that's the, and so that's very exciting. So they're under active negotiations, and it's like CAMLAR, we have to get 100% consensus. And so many countries, most countries actually, support the Weddell Sea Marine Protected Area. And there are a few countries who are still not supporting it and are still asking for more information and more science and information on the threats. The Weddell Sea, some of you may have researched there. It's an amazing place. It's one of these places that you literally, again, can drop a net and find new species every time you go there. It is one of the, like the Ross Sea, actually one of the least damaged. There's been no fishing in the western Weddell Sea. It's very icy. So it is a place that's very ripe for protection, and I hope we will see that go through. As I mentioned, CAMLAR is supposed to meet next month. It's complicated because of it being virtual. So it may not be this year, it may have to be next year, but a lot of people are pushing hard for the Weddell Sea. So it's still ongoing.
There's a question from Veronica. Veronica, I will unmute you.
Okay, thank you. First off, thank you for this amazing talk. It was not only very interesting, very beautiful, and also the political or policy side of it is really fascinating. I have like a billion questions I could ask you, but I cannot ask them all. My question, well, first I would just like to also agree with you what you said about the human rights and the fishing vessels, and I think it is just another example how we cannot separate the ecological and the social question. We need to tackle them together. But the question is, are there any parallels that we can draw to the Arctic? Because that is another frozen part of the world, and with the ice melting and the resources there being much more available, the interest of the players, Russia, Canada, now who all the ones that can possibly file a claim, are there, I mean, of course, there's the problem that in the Arctic there is no land, right? But is there anything that can be done in the Arctic? Is there anything that is being done? And with the melting of the ice, do you think the Antarctic region also might face the pressure for resources?
Yeah, thank you for that, Veronica. I personally think about that question a lot, and it comes to me a lot where some would say, oh, well, we did this in CAMLAR, let's just do it up in the Arctic. I think the Arctic is a lot more complicated because you have sovereign states, you have indigenous people, and in terms of resource frontier, like in the Southern Ocean, mining is banned, like it's just outright banned. So people cannot, countries may be doing science to see where the minerals are, but they cannot touch them. The Arctic is different, right? We don't have good regimes for governing fishing and mining and those sorts of things. And I think another problem is that the perception is being pushed that is the ice is melting and it's opening up and anybody can go. And really, it's still very icy. There is not infrastructure. It's very dangerous. So I think it's, if anything, it's a place we need to keep our eye on, that we need to, the Arctic Council, I know, works to negotiate these things, but to make sure that we have rules in place that will be precautionary. So we don't say, oh, let's set up rules for mining now, when a country then has already mined and spilled, you know? And for fishing, there is a precautionary agreement in place for the sort of shared high seas or international waters. where there is no fishing allowed, where countries who all work in the Arctic Council actually agreed to ban fishing until we know more, which I think is actually a really cool and innovative effort for these Arctic countries. They've been like, okay, lots of people want to fish. We don't have enough information. Let's just all agree to not fish. So it's a nice, like, kind of like the treaty, we'll all agree to disagree. Like, okay, you want this, I want this, let's just not touch it. So we're doing that for the Arctic. So I think there are some lessons to learn from both spaces. And I know there are some Arctic protected areas that individual states have set up, which is quite positive. But I think, yeah, we definitely need stronger regime for the Arctic with all the changes happening. And I certainly hope we can get there. Thank you, Veronica.
There's another question from the chat from Linda. Do you see a positive potential for newly arriving species to enrich local biodiversity? Just 1 second. In the changing environment.
Linda, that's a very good question. A positive potential. I know for the ocean systems, from my understanding, we have not seen invasive species yet. There are definitely shifts in the distribution. So in Antarctica, you have the freezing waters that are the high latitude waters. And then you have Antarctic circumpolar current that goes around the whole continent. And that kind of separates some of the really freezing cold waters from the waters that are mixing with the warmer waters. But those currents, as you can imagine, are changing because the wind regimes are changing and the ice and the whole climate is totally in flux. And so what we're seeing is that some of these species of toothfish, even there's 2 species of toothfish, we're even seeing some of them start to move further north than we've ever seen them. We're starting to see a little bit of overlap of some tuna coming into at least, like, not the high latitude Antarctic, but some of the sub-Antarctic. So we're starting to see some things where you're like, whoa, I never saw it in the sub-Antarctic before, where the system is really shifting. On the land, we're starting to see invasive species. And I think that's a bigger problem, particularly in the sub-Antarctic, when invasives can actually kill, really destroy local birds. The sub-Antarctic islands are critical breeding areas for albatross and penguins and seals. And there's been historic problems with, say, like rats and mice and small mammals really devastating the system. We're seeing invasives with just some insects and plants. And I think it's unclear, like, if that's going to be a huge problem or if that's just going to sort itself out. So I'm not to be totally honest, I'm not totally sure in terms of a positive potential. But Antarctica is one of the few places in the world where we haven't lost a single species. So you hear stories everywhere of, like, biodiversity declines. Antarctica, we don't have great baselines on everything, but from what we know so far, we haven't lost a single species yet, which to me is very positive. So thank you for that question, Linda.
There's a comment from Alison. Amazing science and very instructive on how to best use this information for policy change. Very interesting to see how the system works and how long that process can take. So thank you very much. That's from Alison. I had a curiosity also. So once you define these MPAs, of course, these are like straight lines in the ocean. And what happens to what's just beyond that? Is there also a positive effect, or how does it work?
What do you mean? Like, how is it actually managed, and how do you?
Yeah.
And I mean, good points about it being straight lines. There is a movement among some marine scientists of discussion towards dynamic protected areas, where you might have a protected area that moves with the species and moves with the changing environments. And I think this is where we need to be, right? Like, not just these static lines that don't necessarily encompass truly the ecosystem. So that's an exciting thing that's being discussed, not yet in Antarctica, but elsewhere. So maybe we can apply that. And then, yeah, I mean, in the Southern Ocean, it's an international space. So it unfortunately is really up to the countries to manage and monitor each other, to report each other if they see illegal fishing. And certainly because CAMLR operates on consensus, if there is a country who is illegal fishing, they will be called out and they potentially could be blacklisted. And so there is really good rules in place, I think, for those sort of checks and balances, that if you see a country doing something illegally, it will be brought to the attention of everybody, and they do sort of report on each other. And I think because toothfish is so lucrative, those who fish it want to make sure that they get their catch legally, and they get celebrated for doing it legally, and to call out the other ones to prevent that. So but yeah, it is, I mean, I could talk all day about this, and it's wonderful to have you all here. I wish I could be in person so that we could go grab a coffee or a beer and have these longer conversations, but I really appreciate you having me here today.
Yeah, thanks a lot. I guess there's no further questions. Yeah, so yeah, first of all, thank you very much. Talk was really great, really inspiring. And I guess we all look forward to the next camera meeting, right? So let's see what happens there. And yeah, thank you very much. I would like to thank all the audience for joining us today. And I will just remind you that for now, our climate series is on hold. So we are happy to get suggestions for other speakers. And with this, I first of all wish Cassandra a good day and all of you a good evening. So see you soon. Bye-bye.
Thank you so much. Thank you so much. Great to see you. Have a wonderful day.
Bye.